Extra, read all about it. NASA discovers Earth 2.0. For millennia we have looked up at the night sky and wondered, are we alone in this vast, dark expanse? Today, on November 12, 2025, that question feels more urgent than ever. The headlines are filled with tantalizing names: Kepler-452b, Gliese 1002c, Proxima Centauri b. These are exoplanets, worlds orbiting other suns. Each discovery is a new possibility in our grand cosmic search for life. With powerful telescopes, like the Kepler Space Telescope and the James Webb Space Telescope, that dream has become a scientific reality. We are observing, measuring the dimming of starlight as a planet passes in front of its star, a technique known as the transit method. Our Milky Way galaxy alone is estimated to contain hundreds of billions of stars, and the latest data suggests that, on average, every star has at least one planet. That means there are more planets in our galaxy than there are stars. Somewhere out there, a precious few might be just right. We are cosmic detectives, sifting through an immense catalog of worlds for clues. The journey is long, but the possibility of finding an answer to that age-old question keeps us looking up, full of wonder and hope. Our galaxy is a cosmic zoo of planets, filled with exotic and extreme worlds. We've found hot Jupiters, massive gas giants orbiting so close to their stars that their atmospheres are being boiled away into space. Most of the worlds we've found so far are hostile, inhospitable places, where life as we know it could never gain a foothold. So, what are we looking for? We're on a cosmic Goldilocks quest. We're not looking for a world that's too hot or too cold. We are looking for a world that is just right. This special region around a star is called the habitable zone, or more poetically, the Goldilocks Zone. It's the orbital band where the temperature is potentially perfect for liquid water to exist on a planet's surface. But a planet's location is only the first piece of the puzzle. The type of star it orbits matters immensely. Finding a stable, long-lived star, like our own sun, is a critical part of the search for a truly habitable world. The quest for an Earth-like world is a delicate balancing act, requiring the perfect combination of star, location, and planetary properties. With so many planets being discovered, how do scientists sort the promising from the plain impossible? They use a tool called the Earth Similarity Index, or ESI. Think of it as a cosmic yardstick, a way to measure how Earth-like a distant world might be. The ESI is a scale from 0 to 1, where 1 represents a perfect twin of Earth. It combines several key factors: the planet's radius, its density, the speed it needs to escape its own gravity, and its surface temperature. A high ESI score suggests a rocky planet of a similar size and temperature to Earth. But the ESI is not a habitability score. Beyond the ESI, scientists have a more detailed checklist of criteria for habitability. The more we learn, the more we appreciate the intricate dance of variables that came together to make Earth the vibrant world it is. To understand the search for habitable exoplanets, we don't have to look light years away. We can start right here, in our own solar system. We have a perfect case study in Earth, Venus, and Mars. Earth, our home, is the present, a world in perfect balance, a paradise of liquid water, a stable climate, and a thriving biosphere. Then there is Venus, often called Earth's evil twin. A runaway greenhouse effect has taken hold, trapping heat with a thick, toxic atmosphere. Venus shows us what can happen when a planet gets just a little too much sun. On the other side of Earth is Mars, the red planet. Evidence suggests that billions of years ago, Mars was a warmer, wetter world. But Mars is small, and its weak gravity couldn't hold onto a thick atmosphere. These three worlds serve as our primary benchmarks in the search for life. When we find an exoplanet, we ask, is it an Earth, a Venus, or a Mars? Our own solar system provides a powerful lesson. Now, let's travel beyond our solar system, but not too far. Just 12 light-years away, in the constellation Pisces, lies a small, cool red dwarf star named Gliese 1002. Astronomers have detected the telltale gravitational wobbles of not one, but two planets orbiting this star. Meet Gliese 1002b and Gliese 1002c. What makes them so special is that both of these worlds orbit squarely within their star's habitable zone. Gliese 1002b is the inner planet, with a mass just slightly greater than Earth's. The outer planet, Gliese 1002c, is a bit more massive. Because their star is a cool, dim red dwarf, its habitable zone is much closer than our sun's. Life on a world orbiting a red dwarf would be very different from life on Earth. The light from the star would be a permanent, dim, reddish twilight. The most promising place for life on such a tidally locked planet would be in the Terminator Zone. It's an alien environment, but one where life could conceivably find a way to thrive. Let's journey further out, about 217 light-years from Earth, to the constellation Aquarius. Here we find another red dwarf star, K272, which is smaller and dimmer than our Sun. What's fascinating about this system is that it's not just home to one or two planets, but a compact family of 4 known rocky worlds. The 2 outermost planets, K272d and K272e, are the most interesting for our search. K272e in particular is considered one of the most promising exoplanets discovered so far. Its year is just 24 Earth days long. Like the Exoplanets, the worlds of the K272 system are likely tidally locked to their parent star. The day side would be eternally baked, while the night side would be a frigid wasteland. The close proximity of the planets to each other would also create a spectacular sky. However, the red dwarf nature of the parent star, K272, introduces significant risks. Red dwarfs are known for their violent stellar flares, especially in their youth. It's a cosmic gamble. The long life of a red dwarf offers time for evolution, but its violent temper could extinguish life before it ever begins. Now we arrive at the star of our show, the exoplanet that once captured headlines around the world. Kepler-452b, discovered in 2015 and located about 1,800 light-years away in the constellation Cygnus, this world was hailed as Earth's older bigger cousin. What makes it so special is that it orbits a G-type star, the same type as our own Sun. Kepler-452b orbits its star in 385 days, remarkably similar to Earth's 365-day year. The planet itself is a super-Earth, about 60% larger in diameter than our world. Its mass is estimated to be about 5 times that of Earth, which means the surface gravity would be roughly twice as strong. The star that Kepler-452b orbits is about 1.5 billion years older than our Sun. This means that Kepler-452b has been in the habitable zone for billions of years longer than Earth has even existed. However, its star's advanced age also presents a danger. Kepler-452b may be on the verge of a runaway greenhouse effect, much like the one that turned Venus into a hellscape. It's a world of tantalizing possibilities. A potential water world with vast, deep oceans, or a rocky world entering its final, fiery act. Kepler-452b remains a mystery, a ghost of a potential future for Earth, and a prime example of the kind of world we are searching for. Let's allow our imaginations to take flight, guided by the laws of physics and biology. What could life actually look like on a world like Kepler-452b? The twice-Earth gravity would be the dominant evolutionary pressure. Trees, if they existed, would likely be short and incredibly sturdy, with massive buttressed trunks. Flying creatures would have a much harder time. The landscape itself would be shaped by this immense gravity. Any land animals would need to be built low to the ground, with thick, strong legs and dense skeletons. What about the thicker atmosphere that a super-Earth would likely possess? This dense blanket of air could make the sky appear different. In the deep, vast oceans that might cover Kepler-452b, life could be even more exotic. It's a world of speculation, of course, but it's speculation rooted in science. Our journey through the cosmos, visiting these strange and distant worlds, ultimately leads us back home. It leads us back to Earth. The search for alien life and habitable planets has given us a profound new perspective on our own world. For all the billions of planets we now know to exist, we have not yet found a single one that is confirmed to be like Earth. The more we search, the more we realize how uniquely precious our planet is. The challenges for life on other worlds are immense. We live on a planet that is, for now, in a delicate and perfect balance. This realization brings with it a great responsibility. As we gaze out at the stars with our powerful telescopes, dreaming of other worlds, we must also look down at our own. The stories of Venus and Mars are not just academic, they are cautionary tales written in the language of planetary science. The search for life beyond Earth is one of humanity's grandest scientific adventures. Until the day we receive a signal or find definitive proof of life elsewhere, we must cherish this pale blue dot.